Okay, let's continue and see the relationship of the Hog Hotel with chemistry. What does it have to do with chemistry at all? So, like the hotel, electrons are going to be placed in a diagram that is going to resemble the hotel rooms, just like that. Let's do one example. So, boron, the number of electrons for boron, by looking at the periodic table, we can see that it has 5 electrons. If we want to place these 5 electrons into the hotel or this diagram, we're going to start here on the bottom, just like the pigs. 1, 2, 3, 4, and then this is the last one, 5. So here we're going to start with the S, the first S. So here's going to have one S, and it is full. It has 2 electrons, it is full. 1 S, 2. Then we're going to continue with the second S. 2 S, and it's full. It can hold a maximum of 2 electrons. 2 S, 2. Then we're going to here reach to the 2P. And then we're going to stop at 1. 2P, 1. We stop here. So this one right here is actually the electron configuration for boron. Let's do a larger one. Let's do iodine. So iodine has atomic number of 53. So it has 53 electrons. So let's place them here. We're going to start on the bottom, just like the pigs, and they're going to be facing opposite from each other. And then, just like the pigs, they would rather go into separate rooms and then start filling them out. And then we go to the 4th floor in the hotel. And then they're gonna go, well, I actually start from here. It is full, the P is full. Now we continue with the 4S, that's full. S can have a maximum of 2 electrons. But D, when we go to D, we have 1, 2, 3, 4, and 5, but then we can put the opposite. So D can hold a maximum of 10 electrons. 3D, we go to 4P. P can hold a maximum of 6 electrons. S can always hold a maximum of 2. And then D again. D can hold a maximum of 10 electrons. Look at how we always place them into separate rooms first, and then we're still filling them out before we go to the next level. And then let's count them so far. I'm at 48, so I need 5 more. 1, 2. Okay, so the electron configuration of iodine will look like this. 1s, 2, it is full. 2s, 2, it is full. 2p6, this one is full. 3s2, 3p6, 4s2, then we go to 3d10, 4p6, 5s2, 4d10, and then we stop at 5p5. So this one right here is the electronic configuration for iodine. It's going to tell you where your electrons are located. We're going to see this in more detail in a little bit. Now, we have been talking about trends in all of this, and we looked at the board diagram before, and how if we look at the last energy level, it tells us our number of valence electrons. Well, here we can actually tell the number of valence electrons by looking at the highest s and p orbitals. So if we look at the highest, not the one, the 2 would be highest out of those two, and we add them together, so 2 plus 2 is 4. So the number of valence electrons for carbon would be 4. So just another trend here. Now I want you to look at these questions. How many valence electrons do all of these have? Just by looking at the number here, you are going to be able to tell me it is 1. But here we look at the highest S, all of them are going to end in 1. Here our highest S, they all have a 2. Here the P, they have 1 valence electron, 2, 3, 4, 5. But you need to add the S before him. So 5, 6, 7, 5, 6, 7, 6, 7, 8, 6, 7, 8, and so on. So you can look at that to tell you your number of valence electrons. 4 and 2 would be 6. And 5 and 4. 2 plus 1 is 3. Sorry, I forgot to look at that earlier. But you add the highest S and the highest P to tell your number of valence electrons. Okay, so by looking at in the periods, what do all the configurations in period 2 have in common? What do all the configurations in period 3 and 4 have in common? So answer these on the back of your periodic table or on your separate piece of paper. Okay, so by looking at period 2, it's going to end in 1s2. Period 3, as we approach all the way to the last group, it's going to, all of these are going to be full. S2, S2, P6. And then group 3, S2, S2, P6, S2, P6, and so on. So you can continue with this. So it means that we can actually create a shortcut on how we write these electronic configurations. They all holding the same numbers before them. And then we keep adding and adding more. Like here, they all going to be the same. We're just going to continue to add some more. And you're going to be able to tell me that shortcut when you figure it out. And you're going to tell me later on as well. Okay. So how do we use hogs to help us understand chemistry? This hotel is really in chemistry called the alphabet diagram. It's not a real hotel, but this is what's going to help us place the electrons in their place. Now, the bottom model, which was before this quantum model, describes the motion of the electrons. And Bohr studied this using hydrogen, and he suggested that electrons are found in specific circular orbitals around the nucleus. It's not entirely correct. It is true that electrons are found outside the nucleus, but they're not moving in perfectly circular paths. And this was his model. It was just energy, increasing in energy away from the nucleus. So he said that electrons farther from the nucleus have more energy than those closer to the nucleus. But by doing this, we're gonna see that it has more energy as we go up, and you're gonna start seeing these letters as well, these energy levels as well. But the energy increases as we go up the alpha diagram. So this is the quantum mechanics model, and we need to know these letters and numbers to understand. So I don't know if you can see it well. This is the 1s orbital and how it looks like. The p, we have different types of p, the d's, and the f's, and so on. So let's look at the quantum model. So where outside the nucleus can you find an electron? So we're going to see them in different orbitals. The s, the p, the d, and the f. And the orbitals are regions in space where you're likely to find an electron. The probable location, this is all about statistics and using math and how to do this. So each energy level is subdivided into sub-levels. The S, P, D, and F. Energy 1 has one sublevel and we call it S. Energy level 2 has two sublevels and we call them S and P. Energy level 3 has three sublevels and we call them S, P, and D. And then energy level 4 has four sublevels and we call them S, P, D, and F. So at this point, let's go to C14. You can draw the board diagrams. Later on, you know how to do this. So you can do it for phosphorus, nitrogen, and oxygen.